So what I told you guys yesterday is if it says determine anything and it says missing y coordinate for each point, if it says on the unit circle, just like is a factor, the remainder is 0, on the unit circle, what did I tell you need to find, use, do? Remember? Did you write in your notes? Yeah, you have to use the equation x squared plus y squared equals 1 because that's the equation of the unit circle, right? So if I know an x, I can find a y using this. If they give me a y, I can find an x using this, right? So we're going to go and plug in the x. So we're going to go negative 4 over 5 squared plus y squared we don't know equals 1. 4 over 5 is 16 over 25 because when you square a negative it becomes positive. Plus y squared equals 1. Move the 16 over 25 over, so we get y squared equals 1 minus 16 over 25. And then we can make this 1 be 25 over 25 because it's the same as 1, and then I have a common denominator. So I get y equals 9 over 25. Y squared. So I have y squared equals 9 over 25, and then how do I get y by itself? Square root. When I physically take the square root myself, not when it's written on a page, not when there's a square root already typed on a page. When I physically take the square root myself, what do I have to do? Plus and minus. So once again, this is a grade 10 outcome. Every single time we end anything in Math 30, if you haven't noticed, we finish it with something we learned in grade 10. It's just, it's real. So, grade 10, I feel like, is even slightly more important than grade 11. You learn all your quadratic-y stuff in grade 11, and you learn how to rationalize denominators, but grade 10 is used every single day in 30. So, we learned that we can reduce a radical by taking the square root of the top and the bottom, which we're going to do for this one. And we're going to bring back a grade 10 rule for the next one as well. So here we can square root the top, we can square root the bottom, so we're going to get y equals plus or minus 3 over 5. If all the information they gave me was the coordinate, the point is negative 4, 5, and y, and it's on the unit circle, that would be my answer. I could have 2 points. I could have the point negative 4, 5, and 3 over 5, which would be quadrant 2, or I could have negative 4 over 5 and positive 3, sorry. I'm going to write them out because I don't know what I just said before that. Negative 4 over 5 and then 3 over 5. Or I could have negative 4 over 5 and negative 3 over 5. Right? If they gave me no other information, I could get 2 coordinates. That would be on the unit circle where my x is negative 4 over 5. We agree? But they gave me more information. They actually told me it's in quadrant 2. So which of those two is in quadrant 2? Yeah. Yes, negative 4 over 5 and 3 over 5, because in quadrant 2 my y's are positive. So I have quadrant 1, 2, 3, 4. My x's are negative here, so my y's are positive there. So I'm actually not going to pick the negative version. My y is going to equal 3 over 5. You try B. So this one we're going to go 3 over 10 squared plus y squared equals 1. 3 over 10 is 9 over 100 plus y squared equals 1. And we get y squared equals 1 minus 9 over 100. 1 is just the same for common denominator. 1 would be 100 over 100. So y squared equals 91 over 100. And then you square root. You take square root, you take the plus or minus. So this is where grade 10 comes in. Y equals plus or minus root 91 over 100. In grade 10, and I can even distinctly remember the page in the textbook where this sits. In grade 10, they tell you that that's not the end. Because they teach you that You can put an entire radical over top, or what can you do with the radical sign? You can actually split it. If the whole radical is over top, you can do that, but there's times when splitting the radical is important. And those times when you split the radical, where you put the radical over the numerator and the denominator separately, is when one of those numbers is a perfect square and one of the numbers is not. And in this case, 100 is a perfect square, right? So I can go y equals plus or minus root 91 over root 100. And the reason why I would split that is because root 100 is just 10. So you were taught that in grade 10 as well. You were taught that you do split the radical up when one of them is a perfect square and one of them is not. Because you don't, just because you can't rationalize, or because you can't take the radical of both of them, doesn't mean you can't take the radical of one. So you can split the radical up, being over each separately. Remember that? If not, do you understand that? Okay. Now this one's in quadrant 4. In quadrant 4, my y's are what? My x's are positive and my y's are negative. So the answer to this one is y equals negative root 91 over 10. Okay? Example 7 says, is each point on the unit circle? Well, once again, it says on the unit circle. So that screams we need to use x squared plus y squared equals 1. Give evidence to support it. So the evidence to support it is if I'm given a point, I'm given an x and a y, how can I tell? If left side equals right side, then it is a point. If left side does not equal right side, then it's not. So what the heck is the left side? The left side is x squared plus y squared equals 1. We have x, we have y. When we do checks, the reason when you do a check and you want to prove that something works or does not work, everything on the left stays on the left, everything on the right stays on the right. You don't move anything across, right? You just want to see if left side equals right side. So we're going to plug in 0.65 x, and we're going to square it, plus negative 0.76 squared equals 1. That's supposed to be on the left, but I didn't make it. It doesn't leave myself room. So type into your calculator 0.65 squared plus negative 0.76 squared. What do you get? 1.0001? 3 zeros? Equals 1. Now people will say it's true. Okay, so when we go to checks, when we go to do a check, think of yourself as a 6-year-old. Okay? Why do I say that? Because you're too smart and you overthink things. So go to your 6-year-old little self and say, if I was a 6-year-old and I looked at that, if I was my little London and I looked at that, would she say that those are equal? My little 6-year-old daughter, would she say 0.10001 equals 1? If she looked at them, would she say, yeah, Mom, those look the same? No, she wouldn't, because she doesn't overthink things, because she would have no concept of what the heck that was. She would just say they don't look alike, right? So when you do checks, you have to go back to your 6-year-old self and look at it and say, would I as a 6-year-old say those are the same? And you as a 6-year-old would not, right? You as a person in grade 12 would say, well, I could round it to 1, it's the same, right? Because you have too much knowledge. Now go back to your non-knowledge self, and you'd say, no, those aren't the same. Therefore, these aren't. So I would say left side does not equal right side. So my conclusion is 0.65, comma, negative 0.76 is not a point. Let's see if I said point or coordinate on the unit circle. Is it really close? Is it crazy, crazy, crazy close? If we saw it drawn on the unit circle, we'd probably think it was on the edge of it. Yep. But we checked it and it's not. It's a teeny tiny bit off. Okay? Would it be outside of the unit circle or inside the unit circle? Outside, because the unit circle has a radius of 1, and this technically has a radius of 1.0001. It's a teeny tiny bit outside, so it's actually not on it, right? Which would make sense. B, we know, is on the unit circle because we physically drew it on our unit circle. Would that be a good enough explanation for me on a unit test or the diploma? I physically drew it on my unit circle, so therefore it's on the unit circle. We drew it in class. No. We have to still do it exactly the same. So repeat step. Tell me if that's on the unit circle or not. I kind of gave it away. Okay, we're going to show this using algebra and not rounded decimals and such. So we're going to go square root, negative square root 2 over 2 squared plus negative square root 2 over 2 squared equals 1. So we're checking. So I just will do a little dash so I don't try and run over it. I always say when you're checking, that equal sign is like an electric fence. If you try and cross over it, you get zapped back. You literally can't. Okay, anything on this side tries to get there, can't. Anything on that side tries to go over, you get zapped, you get sent back home. Okay, so when we're checking or we're doing proofs later, we can't move from one side to the other. If we're verifying, we can't move from one side to the other because verifying, proving, checking is showing that this actually works the way it is, right? If you move anything, you're no longer verifying that equation, you're verifying a movement of that equation. Okay? So, when we square a square root, it goes away. We taught that in grade 10. When we square a number, it becomes that number squared, so 4. Remember the 2 distributes to both? That's a grade 10 rule you were taught again as well. And you square the negative sign, it becomes a positive. Plus, you square the square root, it goes away. Square the negative, becomes a positive. Square the number, it's a 4. So remember when you have an exponent up, it goes to both, right? That you're taught. So exponent rules in grade 10. And then it equals 1. Then fraction rules from elementary, junior high. My daughter was started being taught this last year in grade 3 even. But she was given common denominators. You go 2 plus 2 is 4 over 4. Because you need a common denominator to add fractions. 4 over 4 is 1 equals 1. Check. So what we always do is we go right side equals left side. And you can enjoy it because there's your only short form you get for the entire test. RS equals LS. Yep.
Do you have to show all of them?
Well, if it says algebra, then yes, because if not, you're doing calculator, which is graphic, not algebra. Yeah. Yeah.
So if you did it the decimal way, would it be wrong?
Well, the decimal, does it repeat or terminate? Or is it just a crazy decimal that you rounded?
It just terminates.
Does it stop eventually?
Yeah.
Is square root 2 over 2 a decimal that stops?
It does? I don't know.
I don't think it does. Maybe it does. If it actually stopped, you'd be okay with it.
Okay.
Unless they said exact values. But even if it stops, that's an exact value. The only time you can't use decimals is if you round them in the middle. Because if you're rounding them in the middle, you're not really using the number, right?
I don't know if this, I was just wondering, because I didn't do it that way. I was just...
Yeah, no, it doesn't stop. So if you did use the decimals, you could only get away with it if they actually stop.
Okay.
Yeah. Because if not, you can't show them, right? You would be showing that this rounded decimal plus this rounded decimal equals 1.
Okay.
Which it doesn't yet.
So like if you were to show that algebra, and instead of writing 2 over 4, you just wrote 0.5, does that work?
That would be okay. Yeah, because that's still an exact value because it's round. Yeah. So here, if you did a decimal, this root 2 over 2, if you wrote that as a decimal, you'd be in trouble because that's not a terminating decimal. Yeah. Yeah. Does that make sense then? So when you're proving anything, if you're rounding at any point in time, you're not proving that that actual whole number works, right? You're proving a rounded version, and it wouldn't work. Okay? All right. Flip over. I want you to do A and B. Point A, point B. So these questions are really easy if you remember when it says on the unit circle to use x squared plus y squared equals 1, right? If you forget that, you might stare at it longingly and be like, I know there's something, but I can't remember what that something is. So when you see on the unit circle, immediately write x squared plus y squared equals 1, okay? Even if you don't need it, it doesn't harm to put some extra, right? So yeah, 1 over 36 plus y squared equals 1. Y squared, the 1 is going to turn to 36 over 36. So I have a common denominator. Y squared equals 35 over 36, and this is the case of when I take the square root on both sides, I can split it. The reason why I'm going to split it, you only write the plus or minus once, like you don't write it on both of them, right? The reason why I'm going to split it is because 36 is a perfect square. So I'm going to get plus or minus root 35 over 6. If I could reduce 35, say it was 32 instead, I could write it as 4 root 2. And so if it wasn't a 35, say it was root 32, I would expect that you would break that down into 16 times 2, and you would write it as 4 root 2. That is expected, okay, that you reduce it if you can. 35 you can't. There's no perfect squares I can break into 35. Now it's in quadrant 4, and I'm talking about the y. Y's in quadrant 4 are negative y. So y equals negative root 35 over 6. Your homework for tonight is page 187, number 3. Your homework for tonight to hand in at midnight is page 187, number 3 and 4, because that's all I signed on the other day. This is it. If there were ever a time to have homework in on time, this is the night. Like that's nice. Okay? You can hand it in at 1. You don't even have to hand it in twice. Just put that bad boy in there, you know?